This is John Black, Super Chemist. This is not an instructional video. It is just a vlog showing a video account of some chemistry experiments I have done or am learning about. I do not go over all safety concerns, so if you repeat anything in the video, you do it at your own risk.
Put it in the freezer because I want it to cool down, so it's really exothermic, adding a base to a acid, or an acid to a base. And this froze up. And frozen ice takes up more space, so it compressed the air in there and ended up shooting this across the freezer. And same way with this, the thing came out and it flew across the freezer. So hopefully a lot of it was already frozen, and we didn't lose a lot of ammonia, out of there. Still smells about as strong. Keep in mind, this is still dilute. We just wanted to basically see if we could get the ammonia and water out without having the soap. You know what I mean? And now we know we can. So I'm going to basically take the ammonia parts and I'm going to put them in this 2,000 milliliter round bottom flask. And it is chilled down. This stuff is nice and cool. I got a little bit of extra water just to clean this stuff out. Clean this out a little bit. Get every little bit out of there. Okay, so now we got our ammonia solution, ammonia and water. Now when we add the hydrochloric acid, it's going to be very exothermic. You're going to have a lot of smoke come up and stuff like that, because hydrochloric acid's a gas, ammonia is a gas, and ammonium chloride disperses almost like a gas. So I'm going to put this on it. You can see I got a water-cooled condenser. And I'm going to use a funnel up here. And I'm going to pour in the hydrochloric acid that I've been putting in the freezer. And I do have a stir bar here. I'm going to turn it on. And let's see what happens here. But mainly it's there to contain the dust that comes up and the fumes and stuff. They'd have to go through this little coils and stuff and get stuck there, hopefully. So let's pour a little bit of this HCl. Now remember, some of this there is ammonia in here. I'm not even going to check the pH. I already know it's all acidic. Doesn't smell like ammonia at all. Anyways, here goes the first little bit. I got it stirring. It's not producing as much gas or whatever as I thought it would. It's still cool. Okay, my stuff is having trouble getting through this condenser because it's building up pressure as I put it in. So what I'm going to do is I'm going to put this little vent in here. And hopefully that'll help a little bit. See, you got a little pressure point here in case it builds up. It comes a little bit out there. Okay, that definitely helped. Keep in mind when I did this, I have no fan on or no ventilation or anything when I made the ammonia, distilling it, and now I still have no, I don't smell. I'm sure it's not good for you, but I don't smell anything. And we're almost done here with the HCl. Now wash this out with a little water, toss it in. Okay, now we're going to take the pH of this. Ooh, and we see it's red. So we're going to have to add... Okay, so I'm just going to keep adding some of this good ammonia that doesn't have any soap in it, and we'll add it to this reaction thing here. And what I'm going to do is I'm going to keep doing that until I get it close to neutral. I want it to be slightly acidic though. Okay, so I'll just keep teeter-tottering back between a pH of 6 and 9 or whatever, putting a little HCl and a little ammonia and a little HCl, and I just said screw it. I think it's at an 8 right now. It doesn't really matter because any excess you have is going to be a gas, excess ammonia, or excess HCl. So basically all I'm going to do is evaporate this water down just like you regularly would until I can see some kind of crystallization come out. Okay, so this is basically my apparatus. Now you can just put this in a beaker and let, evaporate it into the air. I don't like the fumes though. And like I said, I don't have any ventilation. So I'm just basically setting it up like a regular distillation, right? And I'm going to keep distilling this until I see some kind of precip. When I see precip, I'll stop and I'll pour this out into a preheated beaker. If you don't have it preheated, you might break the beaker that you pour this hot stuff into. So keep that in mind. It's just basically starting to distill right now. You can see it's bubbling up. It's not quite making it over to the receiving flask yet. But like I said, we're just going to distill it down until we see some kind of precip. So I had to go to sleep last night, so I ended up shutting it down at about 200 milliliters, maybe 250. And then I just put it in this beaker, and when I got up today, I boiled it down to about 100 milliliters, and it's starting to precip some stuff out. You can see the sides are starting to get stuff on it. Oh, that's hot. So I'm just going to let it, it's not even boiling really, but I'm going to let it evaporate more water, as much water as I can off of it, even though it started preciping, to get as much stuff out of there as I can. Okay, so there's my ammonium chloride. It's still wet, but there's no, like if I pour it on its side, there's no pool of water, that'll, come together or whatever. But it is soaking wet, just not wet enough for there to be any liquid. So I'm going to throw this in the refrigerator. Okay, if you don't got one, you should probably get one of these. It's like a spatula for cooking or whatever. It really gets salts off of glass real good. And I put this in the freezer, right? And it didn't freeze up. So there isn't that much water is my point. But I'm going to scrape it into this thing here. I have it hooked up to a vacuum. I'm going to turn that on. And just keep scraping it in. See the sides, I don't know if you can see all that, but look at it now. Now it's all gone. It's not like down at the bottom there. And I want to try and push down on it a little bit, And I got some ice cold water here. Maybe try and clean out a little bit of this. And toss it right over top of it. I actually thought it would. Should have sucked it straight through real quick. Now I'm losing a lot of product. But if this was working correctly, that little bit of water would have been sucked right through there, would have been washed completely, and I would have been done. And just to do a comparison, I set this all up the way I just set it up with the last one. Instead of using the 57 milliliters or 60 milliliters, I used double that because this smells twice as much ammonia as that soapy stuff. And I'm using this instead, this clean, hopefully clean. We're going to see if it soaps up or not. But also we're going to compare the yield, because that other bottle also was probably about 5 years old. I've opened it and closed it 100 times. I only use it to test stuff for, qualitative analysis, because it has the soap in it, you know what I mean? So yeah, I diluted it by opening it up so many times, and I don't think it was that strong to begin with. It wasn't never strong like this. This stuff actually stinks like ammonia. Really bad. So we're going to do, so I put twice as much in here, thinking I'd have more than, I have 1 liter of the liquid in here, the ammonia water, and we'll see exactly what the difference is and see if it foams up. Okay, this first thing, this is the ammonium chloride I made from ammonium sulfate and calcium chloride. A long time ago I did a video. This right here is what I just made. I redid that, because remember that my filter didn't work. It wasn't sucking the stuff through it, water. So I redid it. If it was a 1% solution of ammonia in that water, I would have got 30.8 grams, and I got 31 grams here. But this actually, even though it's dry, I bet about a gram of it is water still. You could probably, it's not sticking to anything, but I could tell that it's got at least a gram of water in it. So we got a pretty good deal there. Now this here, this is the one with the no soap in it. Remember, this is the soapy stuff. This is the non-soap. It's about 52 grams, and I think our yield should have been 60, so I got a lot of loss there. I don't know what the deal is with that. But you can see they're all white. I can't really do a yield, percentage yield, because at the end I had to put more ammonia in a little bit and then a little HCl sometimes, and it was, I don't know exactly how much I used. But just to show you what my yield was, 31 grams, probably more like 30 though. And this one's definitely dry. This is bone dry, and it's 52 grams. So obviously the ammonia without the soap had a lot more ammonia in it than the stuff with the soap. Now you might be wondering why, when I neutralized the ammonium hydroxide and the hydrochloric acid, why did I want to get it to be slightly acidic instead of neutral? Either one is fine. But keep in mind, the 5% solution by weight of ammonium chloride in water, which we were making more than 5% by weight, the pH would be like 4.6 to 6 pH. So it would be slightly acidic because you have ammonium ions and you have chloride ions. Chloride comes from a strong acid. The ammonium comes from a weak base. So the salt itself is slightly acidic in solution. Okay. Another thing I wanted to bring up is there is another way to make ammonia. Any ammonium salt mixed with sodium hydroxide will produce ammonia in water. And if you boil it, you can boil it, if you want to really, because if you want to make ammonia gas and put it into a reaction, you don't want to make it from, ammonia in water that you get at the store. You want to go get an ammonium salt, sodium hydroxide, mix them together and a little bit of water. And that way when you boil it, your ammonia will come out of solution. But anyways, I hope you liked the video. That's pretty much it for now. And y'all have a great day, and always remember, science is great.